Hello everyone, this is Sarvahita, Assistant Professor of MCA Department from Rohini College of Engineering and Technology. I am here to discuss a few topics of the subject MC4205 Cyber Security. Let us see about virtual servers and network storage systems from Unit 3. First, let us see what is virtual servers. Virtualization refers to a technology that provides an abstraction of the computing resources used by some software, which thus runs in a simulated environment called a virtual machine. Benefits arising from using the virtualization include the better efficiency in the use of a physical system resources than is typically seen using a single operating system instance. This is particularly evident in the provision of virtualized server systems. The virtualization also provides support for the multiple distinct operating systems and associated applications on the one physical system. This is more commonly seen on the client systems. Virtualization alternatives. A hypervisor is a software that sits between the hardware and the virtual machines and acts as a resource broker. So it allows the multiple virtual machines to safely coexist on a single physical server host and share the host resources. The virtualizing software provides the abstraction of all the physical resources such as processor, memory, network, and storage resources, and thus enables the multiple computing stacks called the virtual machines to be run on a single physical host. A hypervisor performs the following functions: execution management of the virtual machines. This includes the scheduling virtual machines for execution, virtual memory management to ensure the virtual machine isolation from other virtual machines, and context switching between the various processor states. It also includes the isolation of virtual machines to prevent the conflicts in resource usage and emulation of timer and mechanisms. Devices emulation and access control. A hypervisor emulates all network and storage devices that different native drivers in virtual machines are expecting, mediating access to physical devices by different virtual machines, execution of privileged operations by hypervisor for the guest VMs. Instead of being executed directly by the host hardware, certain operations invoked by the guest operating system may have to be executed on its behalf by the hypervisor because of their privileged nature. Management of virtual machines, also called as virtual machine lifecycle management. A hypervisor configures guest virtual machines and controls the virtual machine states, for example, start, pause, stop. Administration of hypervisor platform and hypervisor software. This involves setting parameters for user interactions with the hypervisor host as well as hypervisor software. There are two types of hypervisors distinguished by whether there is an operating system between the hypervisor and the host. Type 1 hypervisor is loaded as the software layer directly onto a physical server, much as an operating system is loaded. This is referred to as native virtualization. A type 1 hypervisor directly controls the physical resources of the host. Once it is installed and configured, the server is then capable of supporting the virtual machines as guests. A type 2 hypervisor exploits the resources and functions of a host operating system and runs as a software module on top of the operating system. This is referred to as hosted virtualization or nested virtualization. A type 2 hypervisor relies on the operating system to handle on the hardware interactions on the hypervisor's behalf. Virtualization security issues. A number of security concerns that result from the use of virtualized systems, including the following: that is, guest operating system isolation. It is important to ensure that the programs executing within a guest operating system can only access and use the resources allocated to it and cannot covertly interact with the programs or data in either of the guest operating system or in the hypervisor. The guest operating system monitoring by the hypervisor. The hypervisor has privileged access to the programs and data in each guest operating system and must be trusted as secure from subversion and compromised use of this access. Virtualized environment security. It is important to ensure the security of an environment, particularly in regard to image and snapshot management, which attackers can attempt to view or modify. Network storage systems. Organizations make use of two broad categories of computer storage for the files, databases, and other data, that is local and networked. Local storage, commonly called direct access storage, that is DAS, is a dedicated digital storage device attached directly to a server or the PC via a cable or residing as an internal drive. Most users' computers and most servers have the direct access storage. The DAS creates data islands because data cannot be easily shared with other servers. Network storage is a term used to describe a storage device, usually many devices packed together, that is available over the network. So this kind of storage maintains the copies of the data across high-speed local area network, that is LAN, connections, and is designed to back up files, databases, and other data to a central location that can be easily accessed via the standard network protocols and tools. Network storage comes in the following topologies, that is storage area network. It is shortly called as SAN. A SAN is a dedicated network that provides access to various types of storage devices, including the tape libraries, optical jukeboxes, and disk arrays. To servers and other devices in the network, a SAN storage device look like locally attached devices. A disk block based storage technology, the SAN is probably the most pervasive form of storage for very large data centers and is the de facto staple of database intensive applications. These applications require the shareable storage, large bandwidth, and support for the distances from rack to rack within the data center. Network attached storage, shortly called as NAS. NAS systems or networked appliances that contain one or more hard drives that are shared with multiple heterogeneous computers. Their specialized role in networks is to store and serve files. The NAS disk drives typically support built-in data protection mechanism, including redundant storage containers or redundant arrays of independent disks, that is shortly called as RAID. The NAS enables file serving responsibilities to be separated from other servers on the network and typically provides a faster data access than the traditional file servers. This is a diagram showing the SAN and NAS in a cloud infrastructure. The SGP recommends the following security measures. Follow the system development and configuration security policies for the design and configuration of network storage system. Be sure that the SANs and NAS are subject to standard security practices, for example configuration, malware protection, change management, patch management, etc. Ensure that the IT facility provides the protection of network storage management consoles and administration interfaces. Store encryption information on network storage systems. Allow for additional security arrangements specific to NAS and SAN. Security arrangements specific to NAS and SAN depend on the type of server configuration, whether virtualization is used, and network configuration. Network management concepts, firewall and IP security. This section provides an overview of network management. Looking at the requirements for the network management, this will provide an idea of scope of the task to be accomplished. To manage the network, it is fundamental to know something about the current status and behavior of that network. Effective management requires a network management system that includes a comprehensive set of data gathering and control tools, and this is integrated with the network hardware and software. Thank you.